Page 159. So this says, consider the following residual plot taken from science. Okay, so this is the residual plot. This is not the actual plot of the data. Agree?
Yes.
Does that make sense? So residual plots, we want to look for patterns. Now, I might not be an art major, but I think that might be a pattern. Agree? Okay. So how many data points are showing that the response variable was higher than what the regression model predicts? Okay. So what you want to do is you want to count all of the dots up above the x-axis. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, maybe 16, 17, 18, 19. Close with 22.
Yeah, it looks so much bunched together.
That could be. I might not be able to count 2, so that might be. So that basically means, because the reason why this couldn't be used, hello. Yeah, come here, buddy. All right, so the reason why you don't want patterns in this is that if you are using interpolation, which is making predictions inside your data, whatever happened between these 2 points, they're acting like this is the line of best fit as a horizontal line. But what happened between here, we would underpredict using this line. So if we were to figure out on this line, there's an over prediction, and it happens often. Now, that's not to say that you don't get under predictions when you have a random scattering of points, but when you have an actual large enough region that you create a pattern, that's bad news. Okay. So how many data points had we did that? Okay. How many data points are showing the response variable was lower than the regression predicts by 2 or more? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 or below. So again, from here over or here over, we definitely falls into our pattern. And this is a thing that we need to make sure that we have a real clear understanding of it. Again, friends, residual plot is like the behind the scenes. A lot of times it's hidden. Okay, it's not shown because, let's just say this. In politics, we've seen a couple political commercials, right? Do you know what any of the candidates really stand for? Or when you watch a commercial, do you watch them mudsling the other candidate nonstop? This person likes to, kick children and drown puppies, and you're like, oh, I don't want to vote for that person. I'm so-and-so, I support this message. And you're like, well, what do you support? Like,
So wait, what's the answer for number 2?
yeah. Was that 19?
No, that was number 1.
Number 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 17.
But it's by 2 or more.
Oh, by 2 or more. Oh, thank you. So
Yeah.
1, maybe 2.
That's what.
Oh, cool. Oh, thank you. Thank you for having a good reading comprehension, unlike this guy.
Nice.
All right.
I do the best I can.
I love it. Describe which values of the explanatory variable reproduce the results of the response variable that are greater than the regression model predicts. Describe which values. Okay. All right. So all of the values that are between 1.5 and like 1.75, that's that region. So describe which values of the explanatory variable. So we're using the x to explain what's going on in the y. will produce result of the response variable that are greater than the regression model predicts. So the prediction model is acting as the horizontal line for y or x, y equals 0, excuse me. Okay, so all of those would give us a greater than what we wanted to predict. Okay, questions on any of those so far? Everybody happy? All right, so oops, let's clear that. All right. So consider the following residual plot. And again, residual plot. This is not our actual data. This is just the vertical distance, either above or below our line of best fit that we're plotting. Okay, so it looks kind of like it could be a random scattering. Some people might be able to argue that it almost seems like there's a sine curve in there of some sort, or a helix. So this would be one. This is harder to see. So it kind of looks like it has this notion in there. It also looks like it could have this notion in there. Okay, so that's like kind of the DNA helix. Is that necessarily a pattern we'd look out for? I'd say if you got that, maybe either collect more data and take a look at it, or examine to see if you really truly do get, that type of thing. That does look like a pattern, but I don't know if that's what we were striving for on this problem. But like, if you stare at dots long enough, you'll be able to sit there and start formulating. Your brain will start formulating patterns, because that's what our brains do. So use an arrow to point to the data point that represents the single best prediction made by the regression equation, and label it A. So I want to see whatever point is the closest. So I would say either this. Oops, look at that. I'd say this one or this one. Let me just make sure. The best prediction made regression, label point A. So I think either one of these points could easily be point A. Okay, they look like they're, and I bet you could sit there and zoom it, have your camera and zoom in on it. You could probably see one's a little bit better than the other, but just looking at it from normal projection, I'd say both of those are as close as possible. If something was falling exactly on the line of best fit, or on the horizontal line, y equals 0, I'd say that would be it. So use an arrow to point to the data point that is the single worst prediction made by the regression equation. So you want to figure out which one is the furthest. So that versus that. Maybe that one. I mean, I'm going to put this one with a question mark, this one maybe even with a question mark. I mean, honestly, if I gave you stuff that was that close, I mean, you can even probably say this one. Being I'm not handing out rulers and you're not measuring this stuff, just as long as you realize that the further away from that horizontal y equals 0 we are is, as far as predictions go. So like those two, either one of those for A, if you label that on a test or quiz, I'm going to give you points. For B, I'd say any of those points like that are labeled. And again, I'm trying to use a finger here, but I'm on a big board. I'm zoomed a lot bigger than yours. So it's going to be tougher, looking at a piece of paper as a student, especially with the graphs that we come up with. And what does the residual plot tell you about the data and the regression model? At this point, I would say it appears to be a random scattering of points. Okay, we don't really have a pattern there. Other ways that we could look at that is if I kind of just drew in vertical lines at each of the tick marks, or as close as I could to the tick marks. If I draw vertical lines in like this, it doesn't, no matter where I draw a vertical line, I still have stuff above and below, so I don't over or under predict based on any of those major regions. So that's kind of a look at it. Even though I kind of started getting you to think about it, there seems to be a pattern where it looks like a DNA helix, okay, or a sine and cosine curve. I don't think that's what we were going towards. And then We have another consider the residual plot down here. Okay, so this is a good one. This is one that you'll see on a test. Okay, that's basically our pattern that we're looking at. They call that a fan pattern. It fans out as you go to the right. Okay, your predictions become closer. You know, once you like from here over, our predictions are much closer. We have closer predictions here, further here, as far as the predictions go. Okay, so a fan pattern is definitely you need to look at to see something. Question back there? Okay. All right. And then explain what is the residual plot in terms of the errors that the regression model is making. You can say something like, the further to the left, the more close our predictions would be to our actual data. Further to the right, the further away our predictions would be from the actual data. Okay, something like that. You know, pretty straightforward, I think. Okay, so as far as the patterns go, does it make sense so far what we've talked about with patterns, things that we know about patterns, ideas about patterns? Okay, how'd y'all feel about that homework? Was that okay? Okay, so Friday, no class because you guys aren't coming. I'll be here in case someone shows up. I know some of the people who play sports have to show up to like half their classes. So I get it. But if you are one of those people that has to show up on Friday, we're just going to chill. Cool? Halloween Thursday?
Yeah.
Huh. Halloween's kind of a fun little holiday, isn't it? All right. All right, 2-9. 2-9. I don't know what page that is. Page 53. Page 53. You with me? Excuse me, I have to blow my nose real quick. I don't.
How much is that?
59.
He cares more about
I
his
think-
schools than CCMC. That's crazy.
2-9. 59, I believe is the page. It's 53?
Yes.
53. Changing pages. 53, 2-9. So time plots. The time plot is simply a scatter plot in which the explanatory variable is based on the passing of time. The x values is time. At 1 second, at 2 seconds, at 3 seconds, so on and so forth. Or dates, because we have years. As you can see, the explanatory variable is the year. The response variable is the inflation rate. Note, a negative value actually means deflation. Okay? A time plot differs from a scatter plot in the following ways. Excuse me. For each value of the explanatory variable, year in this case, can be associated with one outcome. In algebra, we might say a time plot passes the vertical line test, so it's a function. It's a discrete function because we have dots, we don't have a solid line that we drew. Okay, so if you're doing things based on dates or days or hours or minutes, you will only have one y variable for each x variable, which is great. The purpose is to study the change in the response variable over time. Wow, look at that. I don't know what date that is. 19.
That's like 1980, maybe.
Well, this is 1944. This is 1952. So holy cow! Look at these inflation rates. Ay ay ay. Oh, those are scary times. Scary times. It's a good thing it kind of calms down a little bit. We're actually living in a time of inflation right now. You guys are probably finding that you might be making more money, or your parents might be making more money, but the cost of commodities is actually higher. And it's like, oh, it's so-and-so's fault. Come on, guys. It's not so-and-so's fault. It's based on the whole economy. All right. So, the time plot drawn below has all of the data points connected from left to right. This is not mandatory, but it's common. This is called a broken line graph, the kind of graph that is visually easier to follow than a scatter plot because the lines make easier trace from left to right movement of the data. The first scatter plot above, the year-to-year trend becomes difficult to follow, especially between 76 and 84. I don't know what's going on between 76 and 84, but I was alive during then. 76 is the middle. So these values, oh my, it's like an EKG if you connected the dots. Okay. All right, and then, so yearly inflation rate since 1900 through 2011, that definitely looks like a heartbeat. I'd say that's an irregular heart movement. The linear regression plays a slightly different role on the time plot. Regression equation makes predictions, but in this case, there is no point to make such a prediction because each value of the explanatory variable will never occur. So as far as the line graph, if you're going from 1981 to 1982, your line itself might be going up. You have data points based on those 2 years, but what's really taking place between the two, did it automatically jump from 81 to 82, or did they gradually go up or down between the two, or did it stay constant? We don't know. So researchers might study the residual. Bless you. Why does the inflation rate spike higher than the regression model would predict some years? Also, the correlation R is important because it will tell you about the strength of the overall trend of the data. If there's a history of strong positive association, perhaps tells us something about the relationship between variables that might be important. In general, the correlation will tell us about the general predictability of the response variable and can be used to measure how smooth a general linear trend has been provided for the data following the linear trend. Correlation will also be higher as the trend is rising or falling. Okay, so friends, that graph right there doesn't follow a straight line correlation. So if you go and plot this, graph, I imagine you're going to get a correlation that's pretty close to 0. Okay, there's not really a line of best fit that we're doing because we connected our dots in times fashion. So in this type of case, you might not want to look at the correlation as one of your tests if our data follows this. It makes a straight line. Okay, it might not be necessary, and that's okay. But the residuals also will, take place. Residuals, if we tried to make a straight line with this, we would have residuals that would take place. I just don't know what the straight linear equation would be other than we've connected the dots. Oh, here's our favorite, friends. Extrapolation is not to be trusted. Extrapolation, remember, that's making predictions outside of your data. Not to be trusted. But it's something that we use as a tool lots of time. So let's talk about an investment that they often put on television. That all the old people, like my dad's age, contact their children, say, hey, I'm going to invest in this because it was on TV. My best advice to you when you choose to start investing in life, if it's advertised on television, it is not a good investment. They're trying to bail themselves out of their poor investment. You guys want to know what one of the worst investments out there is?
Which one?
Anybody know? What's advertised on TV? Huh? No, politicians are never a good investment.
Car insurance.
Car insurance. No, we're talking about something that you could invest in that doesn't have to do with insurance. Crypto's sometimes on TV. I don't understand enough about crypto. Yes, I know there is the one or two people out there that make trillions off of it. Guys, I want to tell you this. Gold is a horrible investment. Okay? Now, before you're like, yeah, but, the price of gold has not stayed up with the percent of inflation. If the price of gold stayed up with what inflation does, the price of gold should be about $13,000 or $14,000 an ounce. Can someone tell me what the price of gold is today? I bet you guys have some sort of internet device at your phone. Today, yeah. Per ounce. $2,000? 2740?
27.54
Oh, yeah, now it's all changing. So, the price of gold per ounce has not stayed up with the cost of inflation. Now, that doesn't mean gold is losing value. Ooh, look at it fluctuating. Now let's see, do this.
Oh my God, that was.
Okay, so now here's the thing. I just got a text over the weekend from one of the Tempe crew, my old friends in Arizona. And it appears that you can now buy ounces of gold at Costco for $60 over what its current limit is. So Costco bought a whole bunch of gold, and now they're selling it for $60 more than what they're getting. Costco is going to make money off of you. So the cost of gold has not stayed up with the current trends. Because on the other hand, extrapolation is not trustworthy simply because the conditions brought about the pattern we are seeing in the time clock could change drastically. In fact, if enough time passes, things almost certainly will change a lot. If you select any 10-year period from the display in the assignment, that could have predicted any accuracy based on what had come before. On the other hand, the trend of the future is slightly better than guessing. Okay, so if you do choose to do extrapolation, okay, you're using a little bit more of an educated guess to try and predict what might happen in the future. That's better than just arbitrarily rolling the dice on something that you don't know about. Okay? But again, extrapolation is not to be trusted. That's why there's disclaimers on mutual funds and stocks that they can't say that they can't predict future events based on past knowledge. Okay? They put that disclaimer in there. Following the trend in the future slightly better than guessing. Okay, so extrapolation is not trustworthy, but it might be the best forecast we have under the circumstances. So should you make a prediction? Okay, so let's talk about something that they have in Vegas. Here we go. Whoops. Should have hit cancel. I didn't hit cancel. It is a me problem. All right. So, have any of you ever walked through a casino in Vegas or any place else?
Yeah.
Okay. So, there's a game called roulette. Okay. And you basically have 0, 00. Some of the places now have the symbol of the hotel. And then you have numbers 1 through 36. Okay? So, as you're walking by this roulette wheel, which has a little marble spinning around with 0, 00, the symbol of the hotel, as well as 1 to 36, you can bet on any number or symbol to show up. You can bet on any alley or lane of certain numbers to show up. You can bet on entire regions. You can bet red or black. You can bet green. Green are the 0, 00, and the symbol. Okay? So there's all kinds of things you can bet. But they have something, and I can't say this any nicer. The idiot data. Did I spell idiot right? Oh,
IDIOT.
see? You got the idiot here. All right. So, nope, 40 is not a number that would come up. All right. So, the hotel will have the past X amount of wins. So they'll say that 4, 7, 12, 0, 15, 8, 11, 22, 30 and 30, 26, 30, 36, 7, 2, 8, 9, 16, 17, 26, 30, 31, 36, 00, and 0 showed up. So, friends, they have this broadcast big enough and large enough that as you are walking by this particular table, you would be able to see. Is there something that draws your eyes to the table? Is there a certain number that has shown up more than you would think it should?
Zero.
I have 2 zeros. 30.
Yeah, 30 would be good.
So, look at that. Of that many spins of the dice, you have 30 that shows up a whole bunch of times. The reason they want that to take place is they want people to walk by going, wow, look at how many times 30 showed up. 30 must be a lucky number on that table, so I'm going to go to that table and gamble. Okay, that's a pure way of called extrapolation. You are trying to use past results to predict future results. Now, I can assure you, 0, 00, the symbol of the hotel, and 1 through 36 pretty much are all the outcomes that are going to take place. Even if the marble flies off the table, it just becomes a re-roll. So those are the only things that are going to take place on the table. So when you look at it, yeah, the zeros might stick out to you because it happened twice. The 00 is not the same as 0. And then you have 4 30s up there. And they also have each of those colored so you can see if it's red or black or green. The 0, 00, and the symbol are green. And then half the numbers are, the other rest of the numbers are 1 through 36, half are red, and then half are black. Okay? Because you could bet on red, black. So what the casino loves, they love if they got a spin that there's a couple 30s that show up, so you get people that start stacking up 30s for their bet. And then they lose and they're like, oh, I guess it's not hot anymore. And the casino's like, thank you very much for your money. They also have the red and black showing up on there, how many reds and how many blacks. It's like, wow, there's 12 blacks in a row on there, so I'm going to go put money on red. Because red's got to show up. The hardest thing about statistics in gambling is for you to think that you're going to make a prediction based on a new event. And the thing is, the marble and the roulette wheel doesn't remember where it fell last. Okay? And yes, there have been cheating schemes that have taken place. And there's a lot of times where people will overstack a number or understack a number. There's even times where the dealer can say, I have about 80% certainty I can put that marble within this region of these numbers. There was actually one where they did during COVID years, they didn't want people standing around the table. They'd have a dealer and they'd be rolling the thing around, and there's a camera focusing on where the thing would land. And then for COVID, so people were socially distanced. And there was actually a trend where the dealer realized that the number didn't show up on the board right away where the camera was, so he could pick up the marble and put it into, an adjacent slot. So that dealer actually in Atlantic City, New Jersey, was having his friends come in, and his friends were winning a great deal of money because he's like, okay, look, bet on this number. Keep betting on this number. Oh, 7 showed up again. Roll it again. And the dealer would literally, because the camera wouldn't sit there and just show the wheel spinning, it would take a picture of where it fell. So, yeah, there's all kinds of things that take place in the good old state of Nevada. You don't want to get caught up in that stuff. My best advice for you on gambling, don't gamble more than you can't lose. So, would you try 2-9 for tomorrow? Deal?
Sure.
I gotta figure out when chapter 2 is done, or we're only in chapter 2. We gotta finish this chapter at some point.